Dear students, I am Dr. Tamrakar from Bhartiya College of Agricultural Engineering, Durg. I will teach theory of machine of BTech first year, second semester class. An engine running at 150 rpm drive a line shaft by means of a belt. The engine pulley is 750 mm diameter and the pulley on the line shaft being 450 mm. A 900 mm diameter pulley on the line shaft drive a 150 mm diameter pulley keyed to a dynamo shaft. Find the speed of the dynamo shaft when first there is no slip, second there is a slip of 2% on each drive. The data given here N1 equal to 150 rpm, 150 rpm, D1 equal to 750 mm, 750 mm, T2 equal to 450 mm, 450 mm, D3 equal to 900 mm, 900 mm, D4 equal to 150 mm, 150 mm. The arrangement of belt is shown in the figure. The arrangement is shown here in this figure. So here alpha is speed of dynamo shaft, alpha is speed of dynamo shaft, shaft. So when there is no slip, no slip, we know that N4 by N1 equal to D1 into D3 by D2 into D4. Now putting the values, N4 by N1 is 150 equal to 750 into 900 by 450 into 150, that is equal to 10. 450 1 ja, this is 2 ja, and 150 5 ja. So 5 2 ja, this is 10. So and 4 equal to 10 into 150, that is equal to 1500 rpm. This is answer. Second, when there is a slip of 2%, when there is slip of 2%, there is slip of 2%, then we know that on each side 2% each side. Okay, so we know that N4 by N1 equal to D1 into D3 by D2 into D4 multiplied by 1 minus S1 by 100 into 1 minus S2 by 100. So this is N4 by 150 equal to T1 750 into 900 by 450 into 150, 1 minus 2 by 100 and 1 minus 2 by 100. So this comes 9.6. So N4 equal to 9.6 into 150. So this value comes 40 RPM. Okay, this is the answer. We will take some more numericals. Next question. The power is transmitted from a pulley 1 meter diameter running at 200 RPM to a pulley 2.25 meter diameter by means of a belt. Find the speed lost by the one pulley as a result of creep. If the stress on tight and slack side of belt is 1.4 megapascal and 0.5 megapascal respectively, the Young modulus for the material of belt is 100 megapascal. This question is asked in the examination. So here the data given are D1 equal to 1 meter, N1 equal to 200 RPM, 200 revolution per minute, D2 equal to 2.25 meter. In each question, if you find the data given from the question by reading 1 or 2 times the question, then the solution would be easily for you. Sigma 1 equal to 1.4 megapascal is equal to 1.4 into 10 to the power 6 Newton per meter square. Sigma 2 is equal to 0.5 megapascal is equal to 0.5 into 10 to the power 6 Newton पर मीटर स्क्वायर। आपको ये ध्यान रखना है कि यहाँ पर यूनिट्स इंपॉर्टेंट होते हैं। 2.25 मीटर जब mm वाला होगा तो mm वाले में करना पड़ेगा। यहाँ ये मीटर्स में दिया हुआ है तो मीटर वाले यूनिट को हमको प्रेफर करना पड़ता है। एंड E is equal to 100 megapascal. Young modulus is given for this material, that is 100 into 10 to the power 6 Newton per meter square. Okay. Now let T2 is the speed of driven pulley. Let N2 is speed of given pulley, driven pulley. So neglecting the creep, we know that N2 by N1 equal to D1 by D2 on neglecting creep. Neglecting creep. Okay, so N1 N2 equal to this N2 equal to N1 into D1 by D2. Putting the values here, N1 is 200 and D1 by D2 is 1 by 2.25. So this comes 88.9 RPM. 9 RPM. Considering creep, we know that on considering creep, the equation is N2 by N1 equal to D1 by D2 into E plus root sigma 2 by E plus root sigma 1. Now putting the values here, N2 equal to N1, the value of N1 is 200 RPM, 200, and D1 by D2 is 1 by 2.25. This is 2.25, and E plus sigma is 100 into 10 to the power 6 plus square root 0.5 into 10 to the power 6 is divided by 100 into 10 to the power 6 plus square root 1.4 into 10 to the power 6. So on calculating this, the value of N2 comes 88.7 RPM. 88.7 RPM. So when we have not considered the creep, at that time the value of N2 comes 88.9 RPM, and on consideration of creep, the value is come N2 equal to 88.7 RPM. So speed lost by driven pulley due to creep. So speed lost by driven pulley due to creep that is equal to 88.9 minus 88.7. So this comes 0.2 RPM is the speed loss. So you have to solve some more questions that have been asked in the examination, so you will be able to solve number of questions. Now we have to calculate the length of an open belt drive. This is the diagram of open belt drive. Here the driver pulley, its center is O1, and that is different pulley, its center is O2, and here the belt is from here J, T, F, K, H, G and again at J. So we have discussed that in open belt drive, both pulleys rotate in the same direction, clockwise direction. Let R1 and R2 radii of larger and smaller pulley, R1, R2 radii of larger and smaller pulley respectively, larger and smaller pulley respectively, means this radius is R1 and that radius is R2, and X is the distance between both the centers, pulley centers, distance between centers of the pulley O1 to O2, and L is total length of the belt. Capital L is total length of belt, length of BELT, which means from G to E, J to E, F, K, H, G, and again to J. This is the total length of the belt. Let the belt leave the larger pulley at E and G, the smaller pulley at F and H, as shown in the figure. From the geometry of figure, we find that O2M will be perpendicular to O2M will be perpendicular to O1E. This is O2M perpendicular to O1E. Let the angle MO2O1, let angle MO2O1, that is MO2O1. This angle is alpha radians. Then we know that the length of belt, we know the length of belt, capital L equal to arc G, J, E, G, J, E, E, F plus arc F, K, H plus H, G, that is equal to 2 and arc J to E, these are same, so JE twice, and plus EF, this is EF plus arc FK, This is equation number 1. Okay, here 2 EF means EF and GH are the twice. Means if we take the half from the centers, then double of that. Okay. Now from the geometry of the figure, we find that sin alpha equal to O1 M by O1 O2. Here, this is right angle triangle. So this sin alpha means this opposite, alpha opposite is perpendicular, and this is, so that is O1m by O1 O2. That is, the value of O1m is O1 E minus EM. If we replace this with the O1E, that should be replaced by radius. Okay, so this radius minus EM by O1 O2, that is equal to R1 minus R2 by X. This is given X, and O1E is R1, and EM is same as that of the O2F. Okay, so that is R2. So since the alpha is very small, therefore putting here alpha is very small angle, very small angle. So putting the value of sin alpha equal to alpha, so that is alpha equal to R1 minus R2 by X, where alpha is in radians. This is equation number 2. Now arc JE, so arc JE, this JE equal to R1 pi by 2 plus alpha. Here alpha is in radians. This is equation 3. Similarly, arc FK is equal to R2 pi by 2 minus alpha. Here this is 90 minus alpha. Okay, so this is pi by 2 minus alpha. This is equation number 4. Now EF equal to EF. This is EF equal to MO2, that is equal to square root of O1 O2 square OM2, that is MO2, M and O2. This length we have to calculate, that is O1 O2 square minus O1 M square minus O1 M square. So that is equal to square root of X square minus R1 minus R2 square. This is the value of EF. Now here the value of EF comes equal to X square root 1 minus R1 minus R2 by X. This is whole square. Expanding this equation by binomial theorem, EF, we have studied binomial theorem in 11th and 12th. So this is X into 1 minus 1 by 2 R1 minus R2 by x to the power 2 plus neglecting the higher orders, that is equal to EF equal to x minus R1 minus R2 by 2x, R1 minus R2 square by 2x. This is equation number 5. Now substituting the value of J from equation 3, arc Fk from equation 4 and EF from equation 5 in equation number 1. So this equation 1, putting the values of all, this L equal to 2 R1 pi by 2 plus alpha R1 to pi by 2 alpha plus x minus R1 minus R2 square by 2x plus R2 pi by 2 minus alpha. So here this is equal to 2 into R1 into pi by 2 plus R1 alpha plus x minus R1 minus R2 to the power 2 by 2x plus R2 pi by 2 minus R2 alpha. Next, so the value of L equal to 2 into pi by 2 R1 plus R2 R1 plus R2 plus alpha R1 minus R2 taking alpha common plus x minus R1 minus R2 square by 2x equal to pi R1 plus R2, these two have cancelled, plus 2 alpha R1 minus R2 plus 2x minus R1 minus R2 square by x. Now substituting the value of alpha equal to R1 minus R2 by x from equation 2. Alpha equal to R1 minus R2 by x. Here the L equal to pi R1 plus R2 plus 2 and value of alpha is R1 minus R2 by x R1 minus R2 plus 2x minus R1 minus R2 whole square by x. Now L equal to pi R1 plus R2 plus 2 R1 minus R2 whole square by x plus 2x minus R1 minus R2 whole square by x. So in terms of pulley radii, pi R1 plus R2 plus 2x plus R1 minus R2 square by x. In terms of pulley radii, this is the length in terms of pulley radii. So putting the value in terms of pulley diameter, this is pi by 2 d1 plus d2 in terms of diameter plus 2x d1 minus d2 whole square by 4x in terms of diameter, pulley diameter. This is the length of the belt drive for the open belt drive. So we have to solve some numericals on this topic. Thank you.